Peter, I just wanted to go back to that conversation we had earlier, the one regarding that your teacher had said when you're integrating, when you're finding the area between two curves, you subtract the bottom function from the top function and then integrate. And of course, that's completely true. That no problem with that as a thing to do. I just wanted to kind of clarify why that actually happens and why and really to also highlight under what circumstances does it not happen. Now, pretty much whenever you've just got 2 points of intersection, then the top function is clearly defined and there's no problem there. But we'll come to that later. So anyway, if I share my screen at this point, um, let's just see uh, what's happened there. I want to share my screen. That's what I want to do. Um, and as you can see there, in GeoGebra, I drew a graph of the two functions, asked GeoGebra what the area was, and it said it was 36 square units. The functions you can see on my calculator are y minus x squared, oh, sorry, 7 minus x squared and 2x minus 1. And of course, if we graph that, it kind of looks like that, which is what GeoGebra said it should look like. And I wanted to kind of then step out of this and go to the main screen and do as the teacher said, and that is to find the area between the two curves. What we have to do is essentially integrate from -4, which is the lower intercept, to 2, which is the upper intercept. And it's the first function, which is alpha f4 y1, subtract alpha f4 y2 dx. If we do that, the area comes out as 36, as GeoGebra said it would. Now, what is there to do with this? Well, it's probably useful if we go back just to clarify a few things here. If I were to go back to the graph, well, hold on, let's back out of that again. Let's go back to here. If we were to do the integration from -4 to 2 of y1 just by itself, and execute that, comes out as 18. And of course, if we were to go back and do the other one instead, integrate that from the y2 function from -1 to 1, not from -4 to 2, it comes out as -18. And, certainly in terms of what the teacher was saying, you have a choice here. You could just integrate one function, then subtract the integration of the other function. And of course, what's going to happen is it's going to do 18, subtract -18. It's going to add the 18, and of course, the answer is 36. And why, of course, where's the 18 coming from? Where's the -18 coming from? And if we were to go back into the graph again and look at that, if we integrate the function from, let's just see, we're going to integrate the top function. So math 9, and hold on. That's not what I wanted to do. I want to actually go back into to graph mode. Because if we calculate here, it's saying, okay, let's go from the lower limit will, if we made it, let's see, negative of the square root of 7, which is in fact the lower x-intercept, and integrated all the way to 2, which is the point of intersection that we're looking for. That integration actually gives 23.68. The integration across the whole region, of course, only gives 18. So if we instead were to integrate across the whole region, so calculate the integral, which is option 7, this time from -4 through to 2, it now comes out as 18. So even though the first blue area we got was 23, now it's back to 18 because of this negative area here. Now, that some students will kind of want to mess with that a bit, but I'm saying there's no need. There's something else to understand here. And that is, what are you actually doing when you subtract the functions? Now, this is what I'm saying you're doing. Notice here at the point of intersection, 2, 3, the difference between the y values is 0. However, when x is 1, the difference between the y values is 2, 4, 5. And here, when x is 0, the difference is 1 and another 2 and 2 and 2 and another 1. That's 8. Now, the difference between these will be 2, 4, 6, 8, 9. And then the difference in here again will be 8. The difference there will be 5. And the difference there is 0. But notice the differences are all positive. So if we had actually go in, we can demonstrate that further by going back in here and saying, if we calculate, no, what is it? No, I know what we want to do. We want to go in there and ask the calculator to actually calculate y2 minus y1. So what is that? So that'll be alpha f4 y1 subtract alpha f4 y2. And then if we look at the table of values, when x is -4, y1 and y2 are both -9, as you'd expect, but the difference between them is 0. And of course, then if we go down one, when x is -3, they were both negative numbers, but when you subtracted -7 from -2, it gave a positive number. It gave 5. So notice what's happening with the y values. They're all positive and will always be positive because we chose to subtract the bottom function from the top function. And in the entire region we're talking about, there is a bottom function. It's always on the bottom. So when you subtract, the answers are all going to be positive. So no problem with simply, as the teacher said, subtract the functions and integrate. That's always going to work. Now, where would it fail to work? Well, it would fail to work if the two curves intersected each other again. And we were now trying to find the areas of multiple regions. And of course, when it's multiple regions, you need to take care of which is the top function, which is the bottom function. If it's the same all the time, no problem. But of course, if it isn't the same all the time, then you need to deal with that and deal with them separately. Okay? So I'd say at this point we're done. Thank you. I trust that clarifies the entire thing.